Okay, things got sufficiently confused today that I actually want to go through this example again from scratch, so clean slate. So I look through, and there's actually not a bug in my code. There's just a bug in my brain. Okay, so there was nothing wrong with my code. But still, I promised Soraya extra credit, so he gets extra credit. I'm really glad he brought up this example because it's good the way he was thinking about breaking it down. But this is a message to everyone in the class. Anytime you find a bug, or if you manage to stump me that good, chances are you get extra credit. So keep your eyes sharp for those opportunities to keep me honest. Okay. So what I asked you to do was to find a matrix that's scaled by 3 and y, and then translate it by the vector 1 in x, negative 2 in y, or no, sorry, positive 2 in y, and then negative 1 in z. Okay, so scaled by 3 and y, translate by the vector 1, 2, negative 1. And so this is correct. This is doing that. Now, Soraya was trying to break this down and say, well, I don't know what these are all together, but I do know how to scale by itself, and I do know how to translate by itself. So that's good. So he's going and saying, okay, let's scale first. This is just a pure scale. And then let's do a pure translation. So by 1 to negative 1. Okay, and when I do them together, I get that, actually. Okay, so I see it's actually the same result. I just have to be really careful the order that I multiply these. So remember that A is the one I'm doing first. Okay, and then B is the one I do second. So that's crucial. So if I go here and actually make these matrices, so I'll say, let's see, okay, I don't have access to A here, but if I say A is equal to GL matrix dot mat4 values, actually mat4, the 4x4 matrix, you get specified in column major order, so that means I put the columns first. So A, if I go down the column, it's 1, 0, 0, 0, 0, 3, 0, 0. Okay, so first column is 1, 0, 0, 0, 0, 3, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, we got that. Oops, I meant to say from values. Okay. And then we have our matrix B, which is GL matrix dot mat4 dot from values 1, 0, 0, 0. So going down the first column, 0, 1, 0, 0, 0, 0, 1, 0, and then our translation column, which is 1, 2, negative 1, 1. Okay. So what I see is, okay, let me make a matrix which is, we'll say B times A. So remember, that's going to be A is done first and then B, okay? So BA is going to be GL matrix dot mat4 dot multiply BA, BA. Of course, I need to see how annoying this library is. I need to create BA first. So see BA is equal to GL matrix dot mat4 dot create. Okay, now I'm good. Okay, so this is the one I said it was. And let's match it up with here. So, oops, let me pull this out so we can look at them both. Oh darn, it cleared my console there. Okay, so let's check. Let's check to see. So the first column is 1, 0, 0, 0. Then we got 0, 3, 0, 0, so that's good. 0, 0, 1, 0. And then 1, 2, negative 1, 1. Okay, so we're good here, actually. So we see that multiplication, B on the left, A on the right, gives us that. I think what Soraya might have been doing is he was actually putting A on the left, B on the right. So if we do that, and of course it's going to yell at me again that AB is not defined, so just bear with me. AB is equal to GL matrix dot mat4 dot create. Okay, so if we swap the order and we do B first and then A, that's actually the matrix A times B. And we see this matrix ends up, like Soraya said, it actually, in the translation column, it has a 1 and a 6 and a negative 1. Okay, so he was getting this matrix, which translates it up too high. But you'll see that's actually what we get if we just flip the order. So if we do the pure translation first, 1 to -1, and then we do the scale, that's exactly what will happen. So if we translate first and then we scale, that's what happens. It's like saying I've already translated to the vector y plus 2, and then the quantity y plus 2 times 3 is actually 3y plus 6. So this makes perfect sense. We're translating here, but then we're stretching the entire y-axis. So everything gets stretched up, and we end up going up pretty high like that. Okay, so it literally just boiled down to the order of operations here. So my intention with this task was for you to end up with this matrix, which is the result of actually doing the scale first and then doing the translation. So if you actually break it down, you'll see that, whoops, I didn't want to have the scale there, just pure translation. If you actually break it down, you'll see this is what is supposed to happen. And that multiplication with A on the right and B, so B times A, gives you this full thing here. Okay. All right, so that's it. So yeah, we got to pay really close attention. This is a great example of where these things don't commute. And it's also a good example if you weren't sure about how to do this all in one matrix, it's a great idea to split them apart. Oh yeah, and related to that, the last comment I'll make is I'm actually going to, so Michael pointed out today that when we do a rotation, it doesn't look so nice. So it actually ends up squashing this thing if I compose 2 rotations. Actually, even just 1 rotation, I think we'll still see the issue. So see how I kind of squashed it down? That's not so nice. So there's a way to fix that by doing a matrix decomposition called the singular value decomposition, where I can actually split this matrix into 3 parts. Any matrix I can split into 3 parts and do a very careful interpolation of each part instead of trying to do it all at once. That will allow me to keep this thing, if it doesn't change the volume, I can preserve that the whole time. Okay, so rotation doesn't change the volume, so it shouldn't be shrinking like that. So now Michael's got me all obsessed and I want to fix this, so I'll fix it. I don't think it'll take me more than an hour, and it'll be worth it. It'll look nice for posterity. Okay, so that's it. Thanks for humoring me today with my confusion. Don't be worried to be confused yourself.